Hello students and parents, welcome to Concept Clarity. Today we are going to discuss about problems. We are going to see problems set 1. This will cover most of the problems related to displacement time graph. So let's begin with the first problem. First problem. It says a particle, what is it? Particle moves in straight line. Particle moves in a straight line. There are two students, student A and student B. So what the student does is he plots a displacement time graph. Plots displacement time graph. What is it called? Displacement time graph. So the first graph, the student A plots displacement time and he plots the graph something like this. Another student B plots the graph displacement time, he puts it as distance time. He calls it as distance and he calls it as displacement. We needed displacement time graph. So we need to know who is wrong. So obviously B is wrong. It is clearly given that it is the distance graph and it is a displacement graph. But another argument to the fact that this cannot be a displacement graph. Can it be a displacement graph? Yes, it can be a displacement graph, but it is not a distance graph. This is a displacement graph. Displacement can increase or decrease based on the position of the object. But distance is the total path covered. It can only increase, it cannot decrease. Distance cannot decrease, can only increase. But displacement can increase or decrease. I hope this is clear. We'll go to the next problem now. Next problem. This is a position time graph given. What is this? Position time graph. X, T. What can we say about velocity, velocity for this graph? We know that velocity, if we have to check average velocity, then average velocity is the change in displacement by change in time. Now, if I take any two intervals of time, displacement continues to remain same. That means if displacement continues to remain same, the value will be same. X minus x will become divided by delta t. So this will become equal to 0. So the answer, my friends, what is the answer? The answer is average velocity. We can say that when the displacement is is constant, then average velocity is 0. So let us go to our next problem. I'll clear this out. Third problem. There are two. This is a displacement time graph again. This is x. This is t in seconds. This is a. This is b. This is 5. This is 0. So now it is asking. This is plotted for two cars, A and B. A and B. A and B are the two cars. So it's asking which is the correct option. A A is faster than B. B option is B is faster than A. C option, both have same velocity. D option, both cars are accelerating. And E option, both cars have same acceleration. So try to do it. Try to do it. We can see from this graph that A is parallel to B. That means slope, I'll write it as dx by dt, dx by dt of A is similar to the slope of dx by dt of B. That means this represents slope, right? Slope of the line. Slope of A, slope of A is equal to slope of B. It is clearly visible that the angle made with the horizontal is the same. This is theta, this is also theta. So both the angles are same. So what does it mean? If the slope is same of the dx of the displacement by time graph, if it is same, it means dx by dt is nothing but velocity of A is equal to slope of B graph, B line, that is velocity of B. The velocities are same. This option is correct. So that means if this is correct, if velocities are same, then this is wrong and this is wrong. Both cars are accelerating. Both cars are accelerating. Both cars have same acceleration. So if velocities are same, then both cars will have same acceleration, right? Both cars will have same acceleration. This is not. They are accelerating. They are accelerating, right? They are accelerating, but both cars have same acceleration. But is it true that they are accelerating? It may not be, right? As you can see, that the displacement is linearly changing. Displacement is linearly changing. So because it's a straight line, it implies that acceleration of both cars is zero, right? And because acceleration of both cars is zero, that's why they have the same acceleration. I hope this is clear enough. Let's take another problem. Question number 4. The displacement time graph for two particles A and B are straight line inclined at angles 30 degrees and 60 degrees with x axis, which is the time axis, ratio of velocity of A with respect to velocity of B is how much? This is the question. So pause and try to solve it yourself. What is given? Displacement time graph. Sorry, this is T. A and B. A and B are straight line inclined at an angle of 30. So A is at 30. This is A, which is given as 30, and this is B, which is given as 60. So clearly, slope of A, slope of A is less than slope of B. But anyway, it is asking the ratio. Velocity of A is equal to the slope of this line, right? And slope of that line can be given as tan 30, and VB is tan 60. So what is tan 30? What is tan 30? What sign? I forgot this. So I'll use sine by cos, and sine of 30 is 1 on top, and cos of 30 is root 3, right? So 1 by root 3 I'll get here. So tan 32, sin 60 will be uh, root 3, right? So the ratio VA by VB is equal to 1 by root 3 into root 3. It become 1 by 3. So the ratio is 1 by 1 is to 3. This is the ratio. So let's solve another problem. Let us solve one more problem. Sixth problem. This is the displacement. Let's clear it out. Displacement time graph of a particle is below. The displacement time graph. Displacement time, and it's moving. Okay. So this is P, Q. So the topmost portion is Q. R, and this is S. The question is instantaneous velocity of the particle. Instantaneous velocity of particle is negative at which point? So let's try to solve this one. At which point the velocity is negative? Let's plot the graph again here. So the graph is something like this. Okay, this is point Q, this is point P, this is point R, this is point S. Now, in order to find the instantaneous velocity, we draw a tangent. We draw a tangent to that point because a tangent will shrink the time period. A tangent will be a shrinkage of the time period. So now let me draw a tangent at point P. At point P, I'll have a tangent something like this. At point Q, it will be like this. At point R, it will be like this. At point S, it will be like this. So now you can see that the angle P is positive. That means you get a positive slope. Angle Q is 0, right? 10, 10 theta of at point Q will be 0. 10 theta at point P will be positive. See, likewise at point R, this is obtuse. Obtuse means negative. This is acute angle. This is obtuse. At point S, this is acute. So it will be positive. So it's clear here that the particle will be negative at point R. I hope easy peasy for you to solve extra time graph related problems. Let us take one more problem in the same session. Problem number 7. Okay. A particle is moving. Okay. And the xt graph is shown like this. What is shown? Xt graph is shown something like this. This is point A. Moving all the way like this. The particle is moving along along the x-axis. Particle moving along x-axis. Okay, and this is the scale graph. This is the scale graph shown for that particle. This is point D. This is point C, right? This is the displacement in meters. This is time in seconds. So now it is asking speed of particle is 0 at which position? At which position or which point? So where is the speed 0 at this point, at this point, at this point, or this point? So try to solve it yourself. So speed being 0 means slope has to be 0, right? At this point A, slope will be 0. At this point C, slope will be 0. So at point A and C, I solved this similar question before in the previous question. So slope at point A and point C, speed will be 0. Obviously, displacement time graph is will tell you the velocity itself. Speed means velocity. Okay. Okay. Let's clear this out. Let me take one more problem. Shall we take one more problem? Or that is it for you? Ninth problem. Ninth and one more will take after this. A particle moves in a straight line. Okay. It moves in a straight line, and this is the ST time graph which is shown. What is this graph? It's the ST time graph. It moves in a parabolic manner. Okay. This is 0. This is 2 seconds. Find what we have to find? Find V average of particle over a time interval from t is equal to 1 by 2s to t is equal to 1 by 1.5 seconds, 1.2 seconds to 1.5 seconds. So try to solve it. Let me do it here. So this is given as 2 seconds. This is given as 2 seconds means if I have the symmetry, I'll say that this is 1 second, and exactly here will be half second, right? And 1.5 means 15 by 10. So this is 15 by 10. It will be somewhere here, right? 1.5 seconds. 1.5 seconds. All right. In fact, 1.5 second will be exactly at the same level. Okay. Maybe the graph I have drawn little imperfect. Okay. 1.5. Obviously, this is half distance. This is also half distance from 2. Right. Zero point 0.5 distance from each side. So the distances will be at the symmetric. It will be symmetric. This will be symmetric, right? Find the average velocity of the particle. How will you find the average velocity? Can we find the average velocity? Can I take these 2 points? Can I take this as 1 point and this as another point? This is A and this is B. As you know, from the definition of average velocity, we can take a line joining any 2 points. Take a line joining the points at T1 and T2. This is T1 and this is T2, right? This is at T1 and this is T2. So we know at T1, at T1, at T1, what will be the value of S? on the on the s, right? S will be some value, right? We'll say this is va. Let's assume it is as va. I'm not saying this is velocity. Okay, I'm just saying some value va on the s. Okay, s1. Then s2. This is the second point. This is the first point. This is the second point. So s2 will be vb. We know that s1 and s2 is same because they're symmetric, right? They're symmetric. S1 and S2 and S2 is same. So this line joining the two, slope will be 0, right? So what will be the average velocity between the 2 points? And slope is 0. Average velocity is the change of displacement. In this case, they call it s divided by change in time, right? So here change in s is determined by the slope of AB. Change in s by change in time is equal to slope of sorry, this is slope of AB, and slope of AB is 0. So V average is 0 between points T1 and T2. All right. Shall we take up one last problem? Let us take up one last problem and then we'll wind up. The 10th problem. Okay. This is a displacement time graph x, and this is time t. Okay, there is one line. This is B, line B. This is line C, and then there is line A. Okay, here the intercept is 2, here the intercept is 6. All right, the intercept is 6. Now the point where C is intercepting here, this point is at 0.6 on time, and here where it is intercepting is 1.2. Okay, so it is asking, these are the different cars, A, B and C are cars. Which car is having the highest speed? Which car has highest speed? And by looking at the graph itself, we can make out without taking the values. If I draw a line here, if I take this as theta A, and this is let's say theta C, and this is this is theta B, and this is theta A. So theta A to anyway is theta A is slower than the other two. Now we have to determine between B and C. So as you see, B is slightly more inclined towards the end. So that means theta B is slower than theta C. That means speed of car C. C has the highest speed. Okay. Otherwise, if the actual intercepts were given, we could have taken any 2 points, find out delta x, then find out delta t, then find out the slope, and whichever slope is higher, that has the highest speed. So with this, we conclude the problems related to graph. So stay tuned on. Please subscribe, like, and share, and we'll cover even more depth of physics. See you until then.